In this part, we're going to see if we can actually get some evidence for the existence of the phonological loop and for some of the subclaims that are actually being made about that phonological loop. Because, of course, it's easy to throw out some claims about, oh, there's a phonological system and a visuospatial sketchpad system. Well, that's great, but could you provide some evidence that that's actually the case? So the phonological loop, what it does is that it holds both verbal and auditory information. And it doesn't mean that it can't deal with visual information, but it means that anything you see would have to be recoded into some sound first. What I mean by that is, you're maybe looking at your phone right now during this video or a computer. You get a visual image of that computer, and then you can, of course, convert that into phonological loop information by converting it into the word computer or the word phone. So most things can actually be coded in both verbal terms as well as in visual terms. But the phonological loop would handle the verbal code, the phonological code. Now, interestingly enough, people have made predictions about the phonological loop and have actually proposed that it contains two different parts. A phonological store part that just holds the information passively, and that means that after 2 seconds or so it just falls out and decays, and unless you do something with it, it's refreshed with new information. And then the second part is more active and is called articulatory rehearsal, meaning you're actively repeating information in order to prevent decay. And interestingly enough, that passive system, they've actually managed to pinpoint to a specific location in the brain from patient data. So parietal cortex, again, is on the top of your head, right? The left inferior parietal cortex would be on your left hemisphere, the left side of your head, inferior meaning towards the inside, and then the parietal cortex, so it's basically right above the temporal lobe where language is being processed. And then on the other hand, the articulatory rehearsal part is in the left inferior frontal cortex, meaning, again, left side of your brain towards the inside and front of the brain, so the frontal cortex more towards the front. You don't need to remember that, but just in case you're interested, you can learn more about this. And the articulatory rehearsal part is attributed to what's called Broca's area. That's in that particular location. So again, talk is cheap, so you can easily come up with these two systems, but now the question is, can we actually test some predictions? Well, there's a couple of predictions we could come up with. So first of all, if there's this passive system, the phonological store, then it should be that words that sound similar would be harder to remember than words that sound dissimilar, because the sound codes would be very similar, and because of that confusing for the phonological store, because it's this passive system, right? So similar sounding words should be harder to remember than dissimilar sounding words. With respect to articulatory rehearsal, it should be the case that shorter words are easier to remember than longer words, because if you can rehearse them, it takes a shorter amount of time to repeat a short word than it takes to repeat a long word, and therefore shorter words can be repeated more times, and you should be better able to remember those. Last prediction, remembering words should be harder when people need to verbally keep repeating a syllable before recalling the words, because what this would do is actually block the articulatory rehearsal part, and that would then interfere with your ability to remember the information. So again, easy to come up with predictions, but let's actually see if we can test them. So what I'm going to do next is read out 5 words to you, and then when I say go ahead, you write them down, as many as you can remember. And then we'll do it again with a second list of 5 words. So again, grab a piece of paper, grab a pen, and get ready, so I'll start reading the words. Ready? Mac, can, cap, man, map. Go ahead. Now I'm going to read a second list of words. Same thing, 5 words. I'll tell you go ahead and then you write them down. Ready? Pen, pay, cow, bar, rig. Go ahead. So first of all, let's see how you guys did. Right? So the first list of words words was the following: Mac, can, cap, man, map. And then the second list was pen, pay, cow, bar, rig. Now, based on the prediction about the phonological loop, it should be the case that this passive storage system would actually be more confused by the first set of words because they all sound similar than by the second set of words because they sound more different from one another. So if you're acting in line with the model, it should be that you did worse for those first 5 words than you did for those second 5 words. And again, I can't see you, but I know in class that this usually works. So this is because of what's called the phonological similarity effect. Letters or words of similar sounds get confused by this passive storage system, and because of that, the phonological similarity is actually hindering your ability to remember them. So people do worse for similar sounding words than they do for differently sounding words. So people usually do better on list number 2 than on list number 1. Why is that? Because list 1 consists of words that sound more similar than the list of words of the second list of words here. Okay, so that's the first prediction, and that either did or did not work for you. I don't know. Now let's go to the second prediction, and that is that shorter words should be easier to remember than longer words, because again, the articulatory rehearsal system can repeat a short word more quickly than a long word, and as a result, if you can repeat it more, it's easier to remember. So we can test that as well. And again, grab a piece of paper, grab a pen, and I'll go ahead and read off 6 words, and then I'll have you write them down, and then I'll have you read off 6 words again, and then write them down. Ready? Here we go. Beast, bronze, wife, golf, in, limp. Go ahead. All right, now the second set of words. Ready? Alcohol, property, amplifier, police. I have to redo that one. I apologize. I misspoke. All right, again, second list of words. Ready? Alcohol, property, amplifier, officer, gallery, mosquito. Go ahead. Okay, now odds are that in this case you ended up doing better on the second list because I read it twice. But normally speaking, let's first see how you did. Right, here's the list of words. So the first list was beast, bronze, wife, golf, in, limp. Second list was alcohol, property, amplifier, officer, gallery, and mosquito. Normally speaking, people do better on the first list of words than they do on the second list of words. And that is because the first list of words was shorter than the second list of words, meaning there was the same number of words, but the words themselves were actually shorter. Because of the word length, it takes longer to repeat longer words, and because of that, your memory would actually be worse in that case. And that's called the word length effect. So if you look at the word length effect, right, again, if you look at the percentage of recall that people can accomplish for short words versus long words over here, this is typically what you get. Longer words are remembered more poorly than shorter words are. So that's the second prediction, and that typically gets confirmed. Now, the third prediction actually will predict that if you're engaged in a secondary task that would block the articulatory rehearsal loop, then that would suppress the ability to repeat, and that should really damage performance. Before that, I have another slide here where basically if you actually look at this is what I was going to talk about. So what happened in this case is that Baddeley actually did an experiment where he had people remember 2 lists of words, 1 list of longer words, 1 list of shorter words. So you see automobile, apartment, syllogism, basketball, those are all longer words. And then story, car, towel, coffee, and swing are shorter words. So normally speaking, people should do better on the second list than they should on the first list. Except what Baddeley did is that he actually had people say da 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 while they had to remember the words, and then he would tell them go ahead and write them down. Now the point of that is that this repeating da 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 the whole time is blocking your articulatory rehearsal part, so it's actually suppressing your ability to repeat. And then if you look at what that does to the word length effect, is that you can actually wipe it out. So in other words, short words were no longer remembered better than longer words were, because the articulatory rehearsal part being blocked, and this is called articulatory suppression. So speaking will interfere with the operation of the phonological loop. It will prevent you to rehearse the words, and as a result of that, there's no memory benefits for shorter words over longer words. So again, that was predicted by the theory, and that's exactly what you get. Now, interestingly enough too, you can actually look at the phonological similarity effect and the word length effect, and you can see if they interact with each other. You may remember this from statistics. Interaction means that the effect of one independent variable on a dependent variable depends on which level of a second independent variable you're talking about. Now that sounds like a bunch of mumbo jumbo probably, so let me spell it out for you. In this particular case, we have seen two different effects. The word length effect, which shows you that shorter words are easier to remember than longer words. So you see here for similar sounding words or dissimilar sounding words, for both of it is true that short words do better than long words. It's true here for similar sounding words. It's true here for dissimilar sounding words. So the word length effect happens regardless of whether we're talking about similar sounding words or dissimilar words. Okay, that's the first part. The second part is that also the phonological similarity effect happens regardless of whether we're talking about short words or long words. In both cases, right, we look at short words, similar sounding words are remembered more poorly than dissimilar sounding words. And if we look at long words, similar sounding words are remembered more poorly than dissimilar sounding words. So, and in fact, you see that these lines are basically running parallel, which means that they're statistically independent effect. This makes talking about these data easy because you can just make general statements that shorter words are easier to remember than longer words. And you can make a general statement that dissimilar words are easier to remember than similar sounding words. And it doesn't matter which level of the other variable you're talking about. This phonological similarity effect is here for short words. It's just as strong here for long words. So we don't need to talk about word length in that context. And just like that, for the word length effect, short words are remembered better than longer words, regardless of whether the words are dissimilar sounding or similar sounding. So that's what statistical independence means. Now, last thing about the phonological loop, because people have really taken that system and pointed out that it's a really important system when it comes to learning a language. And they think we have actually evolved it in order to be able to learn language. Now, if you think about it, right, when a baby is born, they don't know any language. And they start getting a bunch of input, meaning sounds from the environment. Over time, they will start hearing repetitions of the same sound patterns. So each time, the mother or the father says a word, it's a bunch of syllables together, and that becomes a pattern, right? When they then hear that pattern, the phonological loop can now start repeating that pattern. And as a result of that, these patterns become linked together and they become words. Those words then will become paired later on with what they actually represent in the actual world, right? So what I'm saying is in order for an infant to realize that table is a word, it first needs to hear te and ball together for a whole bunch of times, and it starts picking up on that pattern. By repeating it with the phonological loop, it starts becoming a unit and it may become a word. Now, in the next step then, they would have to then take that sound pattern for table and actually start realizing that that's consistently linked up with what a table looks like, people sitting at a table. So every time that object is present, this sound pattern shows up, and that's kind of how the language starts being linked to the sound patterns. So this is really how meaning and sound patterns starts being link to each other, and that's really a central component for any level of language learning.